Remember to mute that tab as well. Otherwise it starts talking to me. No, wait for that. And there we go. So yeah, thank you very much indeed for coming along to tonight's Knots IoT. I've got a few slides just to go through before we get going. So one of the main things is that we like to run an inclusive meetup here. So there's quite a lot of words there, but really it's just a case of being nice to each other. If you don't feel as though you're feeling welcome or included because of somebody else, then by all means get in touch with me. The best idea is to just do that with a direct message in the Zoom chat. But you can contact me on Twitter at Pete_codes as well if you need to. You can see the code of conduct that we've got there at that link, bit.ly, Knots IoT be nice. So go and check that out if you want a bit more information on that. We'd like to thank our sponsors as well. So we've got my company in there. Normally we'd be sponsored by Rebel at this point and eating their food and drinking their drink, but we're in my office. So I put my my little company down on there. Tech Nottingham have sponsored our Zoom license for us, and JetBrains have sponsored a one of their lovely products for Alan tonight. So Tech Nottingham, I mentioned, they're sponsoring our Zoom license. They're a Midlands based but now global, like everything, community of like-minded people in and about tech. You can join their Slack channel via that link at the bottom there. It's well worth joining. It's an amazing community, and there's channels in their Slack from everything from PHP and IoT all the way through to counting up in hex, if that's what's floating your boat. I mentioned JetBrains. They're sponsoring us one single item from their whole heap of products that they've got, from PHP Storm, WebStorm, and IntelliJ, and everything onwards from that. So if you tweet on the hashtag NotsIoT tonight, then at some point I'll draw out a name out of the list of people that have tweeted, and somebody will win one of their products. So well worth going and checking that out as well. So tonight we've got Sander van der Velde talking about the Things Network. Actually, there was way more to that title there, but it's connecting LoRaWAN devices, the Thing Network, and Azure IoT. So it should be a really interesting talk. Coming up next month on the 24th of February. So actually it's not on our normal third Thursday because it's half term for us in that week. So I moved it back by a week there. And Cliff, I think we'll be talking about how to use the .NET Nano framework with an ESP32, which is really cool that you can program C# on something like an ESP32. So that'll be a good talk to go and listen to as well. At our sister group, .NET Knots, at the end of the month, we've got Lee Engelston talking about machine learning with cartoon characters and Christmas trees. That was actually slated for our November meetup, but Meetup decided it was going to go down, so nobody had the link, and I couldn't email everybody because it was all in Meetup, so that was a nightmare. So that's why this is happening at the end of this month. So that should be good too. If you're interested in developing your career and learning how to get certified with Microsoft's AZ220 certification for IoT, then I've got a Pluralsight course which a few of us have created on to go and help you to pass that exam. So that's worth checking out. I mentioned there earlier that we'll be coming back this year again. Myself, Cliff Aegis, and Maria Anastasia, who has just joined, I believe, present a weekly news show, IoT news show, where we just go through all the latest information about IoT over on Twitch. So that's worth checking out when we come back. And we'll also be bringing back our general Azure show, Azure-ish Live, on that same channel later on in the year as well. So that'll be worth checking out too. And finally, if you're interested in DevOps, then myself and a few others are part of a DevOps-based podcast called the Agile Engineering Podcast. So that's well worth checking out as well on all major providers. So with that, I will stop sharing and let Sander get on with what he wants to do. So thanks very much. Obviously, keep yourself on mute during the talk, and Sander will likely take questions as he goes anyway. It's perfectly fine, but the best idea is to just write your questions in the chat, and then I'll just interrupt Sander when he's got a particularly free moment at that stage. So that tends to be the best idea. And then when he's finished, we'll do a round table anyway, and you can just ask whatever you want at that stage. So over to you, Sander.
Yeah, I will unmute also.
That would help, yeah.
Welcome everybody. Welcome to a presentation about Azure IoT integration. Well, the title from Pete was something about the things at work. What we are going to do is connect LoRaWAN devices to Azure, and those devices themselves, they are connected to the things at work. I myself, I'm not working for the things at work. It's a open source, it's a open community network for LoRa devices, but I'm working for Alten as a IoT solution architect. That's Alten Netherlands. There's also one in UK. And in my spare time, I'm an MVP for Azure, and I'm doing a lot with Azure IoT. And this is one of the examples of the stuff that I do for the community. Today in the presentation, first we will look into LoRa and LoRaWAN. Maybe you've heard of these names and titles. With that information, we look at the things at work, one of the main LoRa platforms, and we will try to do stuff with it with Azure. First Azure IoT Central, and later on actually Azure IoT Hub. If you have some background information, that's great. If it's new to you, no worries. We'll try to figure out how it works and explain how it works.
Sander, just so you're aware, you're not sharing your screen, just in case you didn't know. I'm
not sharing my screen. That's interesting.
Well, of course, I had to present earlier, so that would have stopped you from sharing.
That's why I.
So you can blame me. Perfectly fine.
Of course, it stopped sharing. Well, okay, then
there you go.
This is me, my picture, without the Corona beard, but I still have the same jacket. So that's one. And this is the agenda for today. So that's okay. And well, let's start. Well, first we start with Azure. Azure, the cloud platform from Microsoft. There are hundreds of services in there for doing cloud stuff, and a pretty big part of it is also dedicated to IoT. And this is the Microsoft reference architecture for Azure IoT. On the left, we see devices which are capable to connect to the cloud. And then the main player is the Azure IoT Hub, which is a gateway, and it's capable of having devices connected. Each device has its own registration with its own security keys, and data that comes in is then flowing into the Azure cloud, and finally they will be shown in some business integration, enterprise integration, and adding value to your company. Today we will look at that the red box to the left, getting devices connected. And there's one thing that's interesting to this picture. This is built in mind when devices are actually internet connected. They can connect to Azure, to the Azure IoT Hub. But there are many platforms or devices which are not directly capable to connect to Azure. They have their own platform. How do we do that? Look at, here's a selection of things, devices. To the left, well, you probably know the ESP or the Raspberry Pi, but there's also a particle device in there, a photon, and it is Wi-Fi connected, but the messages are dropped into the particle cloud. It's a third-party cloud, and if you want to get your messages from there into Azure, you have to do something. And the same goes for devices that are connecting with narrowband IoT as a protocol. They will end up at some narrowband IoT protocol provider, or with LoRa, what we are doing today. But the same goes for a smart meter or a smart thermostat or the smart lighting, like the UI that's shown here. Those are separate clouds, separate platforms. And if you want to combine that information together in, for example, Azure, you have to take measure. You have to do something with integration. Okay, that's about integration. Let's look into that LoRa stuff, that low powered devices. That's the group of devices we're talking about. And here's some comparison of wireless protocols. You know about Wi-Fi and Bluetooth, the yellow boxes, but there's also that green range, like Sigfox and LTE, narrowband, and LoRa. And the most interesting columns are, for example, the range. If you can look at the range of narrowband IoT, 1 to 10 kilometers, which is pretty okay. LoRa, 5 to 20 kilometers of communication from a single device. For example, a device like this one, this is just a Arduino Uno with a chip on it, and well, okay, you need maybe a bigger antenna. I'm not sure about that, but these are capable of communicating over kilometers, miles, in the UK, of course. And the other column is, for example, the battery life. These devices tend to be low powered, so depending on the amount of messages that you try to send, it can have a battery life of up to 10 years, as stated here in this picture. If that's true, well, that depends on a number of factors. And third is that the throughput is quite low. These devices, this protocol, these wireless technologies are not that fast with the communication. So if we combine it, we see something like a promise of up to 10 kilometers or even a larger distance, battery which will last for years, we hope. And we accept that we are not capable of sending a lot of information, or even it's only one way. LoRa, what we will use is a two-way communication, but there are also solutions which are only communicating in one way. So with the laws of physics in mind, the longer the range of communication, the lower the bandwidth is that we can use. Think about if you want to send a message over a long range, or a large message over a long range, there's some chances that the signal is corrupted, that somebody else tries to send a message and then your message is corrupted. And of course, the longer the range, the more power you need. There's the radiation goes in all directions, so you need quite some power. And then suddenly your battery will not last up to 10 years, but only a few days, if that's within scope. So you have to pick two: long range, high speed, or low power. Well, in this case, we go for the low power and long distance. And that means that we have a topology like this. We have the nodes, that are the sensors, and they are communicating to some gateway. Well, it's a fairly recognizable pattern. It's the same with your cell phone. You have to be somewhere near a tower, cell tower, or a gateway to communicate. Well, the same goes for here. The gateway themselves, they are internet connected, or at least capable to connect to the backend of your provider. And from there, you can make a secure connection towards your own application. And the interesting part is that the gateways themselves, they get all the messages, maybe messages from your own sensors, the one that you have laying around in the field, but they can also pick up messages from other users of the same network. So that's why there's a encrypted communication between the node and the backend. From there, the messages are decrypted and they are made available to your application server. And maybe you need another way to have a secure communication between the network server and the application server, but at least you have a end-to-end encryption. And that's pretty important because we are talking about an example of a LoRa network. That's the Things network, and that's a community project. It started in Amsterdam. That's why I got involved at some point, that they asked, well, okay, we want to have a workshop to show how this can be connected to the Azure cloud. And I was immediately hooked. I got some of these LoRa sensors years back, and a gateway, because there was no gateway here in my neighborhood. So I put up one. It's not this one, or this is some picture from the internet that I took, but all other neighbors in my neighborhood can all use my gateway. It's not that powerful. I have a new antenna laying around, and I want to fix my my gateway outdoors, so I have a longer range. But other people are sending messages through my gateway, and that's okay. I'm not capable of seeing what it is and what it means, but I know that messages pass through. And the Things that work, it offers me a long-range communication and a low-power solution, and it provides uplink and downlink. And if you think, okay, this is something that I need, well, and you need this LoRa network, well, actually you are part of the network if you put a gateway in your neighborhood. There's one thing, it's a community network. So if you want to use it, there's some kind of fair use policy. And you could be throttled when you send a lot of information over the internet, over the network. So take care about that. There is even a map of the world from the Things that work, and I took this picture from your region, Nottingham, and there are not that much gateways. Actually, I think there are some black dots over there from past gateways which have been there. At this moment, only one is active. Maybe you know where it is. I'm not known to the neighborhood over there, but it's near the Nottingham Hockey Center. So I see somebody nodding, so that's okay. I hope to see in a few months that suddenly there are more gateways in your region. I will look it up in a few weeks. So as I said, you find yourself a gateway. You buy some parts and you build your own sensor like this one. Or you go to the shop and you buy one which is already made available by some commercial party. For example, this one, I have a number of these sensors. This is an interesting one. This is a parking sensor. you glue it to the ground, and it's strong enough to have to cope with the weight of a car. But if a car is parked on above this sensor, it will sense the change of the magnetic field, and it will send a message that something is there. So you can make your parking lots a little bit smarter with that. Today we will do a lot with these sensors from SenseCAD. Seat Studio is behind it, and these are really nice sensors, like this one for CO2 measurements. This part is the battery, and there's as you can see, you can detach them, and there's a switch to put it on and off again, and you can close it again. And I have a bunch of them, like this one, or a air pressure meter like this one. And well, they can have some rain. Okay, that's really nice. This is a really nice little gadget. You can attach it to a table, and it can or next to a door, and it can measure if there's some occupancy. So there's one with a peer sensor. Mine is just with a read sensor and a magnetic sensor, so it can measure if a door is open or closed, for example. Then the one that I already have shown in before this session, there's a Mousetrap also available. There's a commercial party who offers these electronic mousetraps. I'm not going to demonstrate it. It works, but I don't want to lose a finger. And when it gives a status when there's a mouse in there or not, and it also once in a while sends a message. This is the battery status. So if the battery runs out, you know why. That it's actually happening. And there's one in there in the picture. It's not a sensor, it's a gateway, a really small one. It's just like this. And this sensor is for in-house, indoor gateway. It's nice, it's pretty cheap, and it works with LoRa sensors, information coming in, and then it attaches itself to a Wi-Fi. You can program it to get it connected to a Wi-Fi. And the interesting thing is that it also works with a USB-C. So you can make this a mobile gateway. If you have some area where you want to do something with LoRa only at that spot, you take your mobile phone, you take this one, and with a power bank, and you're up and running. So the demo gods already fooled me once. I'm hoping that they leave me alone. And I'm able to do a demonstration about the LoRaWAN platform. Let's connect a sensor. Why not? Okay, so the Things network, they have a portal, really convenient. You have to make an account for free, and then you are able to attach your gateways and your applications. If we look to the right, there's a page with the gateways, and at this moment I'm the owner of 2 gateways. This is the one which is actually connected, as you can see. And the other one is the one that I have in my hand, so it's disconnected for some reason. So okay, we will use that Mqtt gateway today. And we want to work with sensors, so we need a so-called application, and I already created one. It saved me 5 seconds, and with that I can start adding sensors, devices. There are no devices in here yet, so let's add one. Okay, if you have your sensor built yourself, you can add one manually, and then you need to provide some secrets. But there's a really interesting thing with things at work. They recently came with version 3 of this portal, and there is a registry of devices, and we will work with this sensor. Yeah, ooh, the biggest one that I have. It's a sensor for detecting light. So really nice. And it's from SenseCap. So if I go to the directory and I see SenseCap, and the model that I have is this wireless light sensor. There's some firmware stuff in there, and we are living in the EU. So I pick that one, and there's a picture in the frequency is this one. So I have to fill in these secrets, and I have these secrets available. So I have to look for a file that I have here. And first I go for the application EOI. I'm not going too much into details about what these keys mean, but the combination of these three keys make it possible for a device to being registered and to once it connects, it is trusted. And I have to give it a beautiful name. So I give it something like Light01, and I register it. And now I have a device registered. Well, the device is created. So I'm opening it and I'm switching it on, and I reset it. This is something we will see a number of times today, that I reset it. And here you can see already that it tries to accept the device. And let's wait. And here is a message that I got from the device. And it says something like, okay, the battery status is 65, so I know how much power there is. And the interval is 3600. So I think that's something like it sends a message once an hour. Okay, that's the reason why I will reset the device a number of times today, because then it speeds up a little bit. And we also see some other information. You have to be know that we want to communicate small messages, and this JSON message is not small, but this is not actually the message sent by the device. The device itself sends something like this. This is a byte array made human readable, but there's some transformation between the actual payload and the decoded payload, a decoder. And that's done with the payload formatters. We have payload formatters available, which will turn a incoming byte array from the uplink to JSON. And an example of that is seen here, because you can add them yourself. But with the repository, I already get one for free. I don't have to upload or program it myself. That's something done by SenseCap. And for example, well, I demonstrated a message like this with the battery level and the interval. So that's really easy, but of course, we are interested in the actual light level. And let's figure out. Yeah, there it is. It says something like, I have a measurement ID 4099 with some measurement value. And luckily, there is some documentation, and that says 4099 light intensity. So I got a light intensity message. I think this proves that it works. So that's okay. So how did I get those secrets of the device? Because you to buy a device, well, on the device there is a sticker, and normally the information on the device itself is not actually the secrets that have to be filled in the portal. In this case, there's an API from SenseCap where I can fill in the stuff, and I get a message like this, and oh, there it is. There you see the information that I need. And well, we actually already did all these steps. We are capable of doing of retrieving uplink messages, and there's also a possibility to do something with downlink to send a message back to a device, but that can not be demonstrated in the portal. On the other hand, keep in mind, sending a downstream message is not always possible. You can only send a downlink message when an uplink message arrives. So if the device sends a message, it waits for a number of seconds, and it's the portal, the backend of our platform must be smart enough to say, okay, there is a message available. Let's send it back to the gateway, to the device, and then the device says, okay, I've received it, and it shuts down again, just to save battery. So if you're interested in commands, every 1 hour, you first have to send an uplink message.
Sander, Chris Claxton's asked, how did you configure the sensor? And Chris, do you mean how did he configure the necessary details to connect it to Things Network, or something else?
Yeah, just to connect it to TTN.
Well, it just starts communicating over the specific band, the frequency band, and I have a gateway here, which is trusted to the Things Network. So that's why my message will end up in the Things Network, because all the keys are okay, and then it arrives. If my gateway is from another cloud platform, the message will get lost.
So is it pre-configured to connect to TTN when you buy it?
No, it's just ready to send messages over the protocol. And
okay, it's a LoRaWAN, sends LoRaWAN messages, and that LoRaWAN message is picked up and relayed. It's just a generic message, is it?
Correct. It's a open standard.
Yeah. Okay.
So if you're,
then you can find it. So it'll be there somewhere. So it gets registered on TTN. It'll get registered as a message from a device with a certain ID, and then you can find it.
Yeah, and the gateway that I have could also have been programmed for another provider. I'm not sure if they can be programmed to 2 or 3 providers next to each other. So you can have multiple sensors, multiple platforms using the same gateways. I'm not sure about that.
Okay, so understand that. So it sends out a message with LoRaWAN. Your gateway receives it. Your gateway is configured to forward those messages to TTN. So TTN will pick that up as a message from our device. So is there some sticker on the device where you can then, you've got an ID that you can then search for or something, or some.
Yes, there's a sticker on here with the something that will give me the secrets of the identity of this single device. And with that combination of the dev EUI, the app EUI, and the app key, that together bounds the Things Network and this sensor together.
Okay. Thanks.
Okay. So the messages arrive at the Things Network, but yeah, that's yeah, okay, that's a nice user interface, but it's not really handy. It's not a real dashboard. So if you want to get access to those messages, you can think about setting up some kind of integration. And there are multiple kinds of integration, like integration with Mqtt. There is an Azure IoT Hub. We will look at that later on. But there's also something called a webhook. Each message that arrives can be sent to a other platform if it supports a webhook. And a webhook is normally something like an HTTP endpoint. And you have to register it, and it will try to send a message to that. So if you're doing something with Cayenne, the messages are arriving already. Well, I will go for the custom webhook, because what I did, let me do this, delete URL, okay. And this is a webhook site. It's just a test site for incoming webhook messages. So let's add that one, test webhook, and it's in the format of JSON, and this is the URL, and I'm interested in the uplink messages. As you can see, there are more kinds of messages, but I'm interested in the uplink messages. So, well, the webhook is running. I go to live data, and now I do that reset trick. So I push the button, I attach it again. If I'm a little bit lucky, you see that it tries to accept, and then it will send that message with the battery status, etc. We have to wait for that. And there it is. There's the message. So if I go to the webhook, we see actually the message coming in. Here it is. So this is just an endpoint. So if you have an endpoint, you are capable of receiving messages. If nobody can guess this endpoint, well, then you're a little bit more secure. What is interesting in the message that we get, for example, of course, the application name, the device name, of course, the actual decoded payloads, and we also get a list of gateways. As you can see, at this moment, there's only one gateway who got this message. If there could be multiple gateways in the neighborhood, and all these messages are then combined into one uplink message. And I can see, for example, the signal strength and that says something about the distance between the sensor and the gateway. So that's why we technically could do some kind of triangulation between a sensor and multiple gateways. But keep in mind, triangulation is pretty hard, because if there are reflections with buildings, or you have a really cheap radio chip in here, things can get messy, and then it can take days before you have a position which is a few hundred meters accurate. So triangulation, it's nice, but you have to put some time into it. But as you can see, we are capable of getting messages from the things network into our own solution. Well, one of the solutions that was offered by Microsoft almost directly was the integration with IoT Central. So we have a device, it sends a payload message, and we can add a webhook to a Azure function. There's some extra tooling that you need. We can install it, and then an Azure Function sends the data towards the IoT Central software as a service IoT platform. For those who are unfamiliar with it, this is the landing page of Azure IoT Central. And for example, this is an example application. If it starts at some point, as you can see, I can have devices, I can have rules, some analytics, you can do some alerting if you want to. And there's also this feature of device templates. So you say, okay, for this sensor, the message that comes in, it looks like this. For example, the ambient temperature is there, or a battery voltage and some extra stuff. That together builds up the message that's coming in. And once you have set up this device template, you can actually attach sensors to it. You can create a sensor registration, and well, then you can even get some dashboarding. There's some dashboarding involved also. Really nice. It's of course all built on the platform as a service Azure IoT resources like the IoT Hub, like Stream Analytics, like time series insight. So this is a simple solution. If you're not a programmer or you're not very familiar with cloud, then you can use this one. Well, what I did, I created an application, and from that application, well, actually there's no device template in there. We don't need it for now. From that application, I took the some secrets. That's the this scope ID and some shared access key. Why did I take it? I can show that there, because we are going to demonstrate it. There is a bridge available from Microsoft, that Azure function that we need. There's a beautiful page in there in the documentation, and there's even a deploy function button, and all it needs, it goes to Azure, because with Azure you can create your infrastructure by code. With some ARM templates, you can create your own resources. And well, the designer, developer of this solution, they did it for us. They will create an Azure function with some logic in there, which can ingest messages from third-party clouds, for example, the things that work, and it will send it to your application in IoT Central. But for that, it needs the scope ID and the SAS key. So I hope that's clear. It will end up in an endpoint, and it will send the messages to my application. Actually, let's look at it, because I already generated it up front. Here we see the Azure function, and if I go into the Azure function, there is a function called IoT Central integration, and if I look at it, it's just a bag of Node.js, of JavaScript. That's this stuff. Only this is set up quite smart, because there's data, there's code in here. As you can see, there's some extra stuff in there. This Azure function, it has a endpoint. This is the endpoint. Let's make a copy of it. This code can be used by many platforms. If you have a platform of your own, which is capable of doing something with webhooks, you can point it to this Azure function. and send the data directly into the IoT Central. But there's of course one thing that we have to do. The message that we expect that we get is something like this. This is a LoRaWAN network communication, the things network communication, the message. So we have the device ID and we have the decoded payload over here. And if we look at the documentation, where was it? I had it somewhere. That's here. One back. If we look at the documentation, you can see you can connect a particle cloud to it, but you have to make some adjustments to the code. Or you can connect Sigfox, or you can connect the things that work. But to do that, we have to do something with the incoming message. And we are only interested in the device ID and the actual body. It's called measurements. So that's why from the incoming message, we go for that device ID and the decoded message inside the uplink message. I hope you can recognize that from this raw message, decoded payload and the device ID inside the end device IDs. Okay. So actually, let's see it in action. I put a logging in my Azure function. I put it on, and I go to the integration webhooks, and I add an extra webhook, and I call it IoT Central. I'm not sure if there's a space there, so let's do it without space. I copied the Azure websites and the URL of my Azure function. I'm interested in the uplink messages, and I say add webhook, and now it's running. So again, with the message, the sensor, I detach it, I push the button, yeah, it's reset. I close it again, and in the live data, I think that's some kind of timeout. Let's see what happens. Forward, join accepted message. Okay, it's doing something. And actually here is the message. So let's go to the, yeah, there it is. Here's the Azure function, and we see that it say, hey, there's a device with, well, we have to register it in Azure IoT Central, and we send the data towards Azure IoT Central for this particular device. So message comes into the things network console, and it sends it to the Azure function, and Azure Functions puts the message into Azure IoT Central. So if I look here, we see that there is a device, Light01, and it's unassigned. There's no device template, so you can do the fancy tooling with all the automatic mapping towards the dashboards. We just look at the raw incoming message, and actually we see some messages coming in. Let's take one. There's a lot of messages in there. And here it is. You can see this is the battery and this is the interval. And there should be somewhere the message of the actual telemetry. Okay, it's there. So we are now capable of connecting our things network platform to Azure, in this case, the IoT Hub inside IoT Central. But if you just try to do something fancy with that Azure function, well, you can do whatever you want. So integration using these Azure Function endpoints, okay, it works. There's only one thing, it's a one-way ticket. It's just ingesting. We are not capable of sending information back. If we want to do that, we should think about more fancy solutions. So first, the slide regarding the change in the Azure function. And if we do that, then we will see that devices are capable to be registered inside IoT Central, and we see the incoming messages. But what about IoT Hub integration? If we want to do something with the IoT Hub, we need to put something in between. And the first thing that I did almost 5 years ago was working with a Mqtt broker. So I just built a console application, and I in C# with an Mqtt client, and I had the correct secrets, and then I was capable of listening to all the Mqtt messages sent by the Things network over Mqtt to, well, any Mqtt client that is there. And actually I have a example of that somewhere. Here it is. Here we see Visual Studio and the application already running. You see that there's something that I have to tell, like I'm using a Mqtt client which will communicate with the Things network. I need to provide some information about, for example, a single device that I'm interested in the uplink messages. I could use something like this with the hash sign, and then I can get all the messages for all devices that are attached to the Things network. And then I get the incoming message. In this case, I'm just writing them to the screen. Actually, I can show you here. Here we see actually the running application, where we can see, okay, that a device sends some information. Can we see something? Well, there's some with frequency. Here's the measurement information, as you can see, 4099, and this is the amount of light that is seen. So this is working okay. Actually, you can even do something like sending a message if you want to, because the client is stateful, and if you attach this to the IoT Hub and you look at the IoT and you ask for a certain device, are there any messages at this moment to be sent towards the device? Then you can pick it up. And that's done with something like this. You do a downlink push of the message to a certain device. In this case, I'm sending 66 in decimal, and that's something like 42 in hex decimal. I'm not actually sending this because I have no clue what will happen with this device. Maybe I break it, that it will say, hey, there's some downlink message coming in. I'm not sure what will happen. There are specifications. You can actually program these, but I didn't find the time to actually look into the message that I have to send. For example, this one is communicating every 1 hour, and I have another sensor like this temperature and humidity sensor. It will send a message every 5 minutes, and that's because with the uplink message you can reprogram this device. It's not really fixed. There are some sensors, some properties, some configuration properties that you can change of this device. So that's okay, an MQTT client. But the problem with an MQTT client is it has to run continuously. So how do you do that in Azure? Well, one way is to have a VM running with your piece of code. Another solution is working with a web job. An app service like a web app or an Azure Function has the capabilities to support web jobs. And a web job could be actually just a console application, a C# console application, which it starts, and if it crashes or whatever, it will try to start it again, which is perfectly for what we have to do. But then again, there are costs involved in having a web app running or an Azure Function running. So this does not come for free. So this was something that we did 5 years ago already. But a few months ago, I was, well, the things that worked, somebody reached out to me and they said, hey, we've done some stuff with you in the past. We are working on a full connection between Azure and the things that work. Are you willing to look at it and give some comments? Well, of course, I was interested. Always fun to see some new stuff. And I found some little things that could be better and some big things that they are still thinking about how to fix it or how to change it. But the promise of this integration is, well, stellar. First of all, with this solution, we don't have to register devices in both worlds. The things that work and the IoT Hub, those are two separate registries for devices. How about if we only have to care about one and the other one is automatically updated? And that's something that they promise. They, if I register a device in the Azure IoT Hub, it will be sent as a message that there's a new device, and it will be created into the things that work. They provide uplink messages, and they also provide downlink communication with the default device twin configuration of an IoT Hub. In the IoT Hub, you can register a device, and each device has a so-called twin, device twin, and you can say, okay, I have some desired properties that I want to have sent to the device. And if the device comes online, or it attaches, it looks, hey, there is some desired state. I take it, there's some program running, and it then reports back what's happening. So what they did with the things that work, each message that is sent towards the IoT Hub is sent both as a telemetry message, as a stream, and as a reported property. And in the desired property, I can send a downlink message. So let's again hope that the gods are forgiving and that they allow me to give a demonstration. Again, we need some kind of logic in between. There's not a direct connection possible. We need some kind of intermediate solution. And keep in mind, if you see this, something like this could work for other solutions also. If they have input and output and registry endpoints, you could do something similar like to this. To work with the IoT Hub, well, we already noticed the right page. We already noticed that there's something like the Azure IoT Hub, and in there we can see that there are credential secrets, which have to be known at the broker, which is put in between. And we get back some kind of information, the IoT Hub information and the access key. How is this done? If I look at this documentation, I believe, yeah, this is the documentation. They have this deploy template. This looks familiar to us. Again, the Azure portal is opened, and once it is there, it will ask us some information. And that's the stack cluster address, the stack application ID, and the stack API key. Hey, that's the stuff that we see here, application ID, API key, and the cluster address. So you fill that into the here. You can even tweak the sizes of the resources that you want to have generated. And then you're good to go. So if you push that, at some point, resources will be created in the Azure portal. Actually, I already did it just to save some time. And we see that it generates an IoT Hub and an Azure Function and an Event Hub. That's the main parts that we are using. So that's something that you have to know. You have to fill in the 3 secrets. You run the wizard, resources are created, and you get back that IoT Hub owner, IoT Hub host name, and a secret for the policy. You fill it in, you hit the save button, and you're good to go. If I have my button, you say the save, or in this case the update, then there's a connection made. Actually, the connection was already made in here. So let's look into the IoT Hub. For those who have not seen an IoT Hub yet, it's just an Azure service. It's capable of ingesting data from devices. You see that I tested already with some messages last couple of days. And there's one IoT device in there. Hey, why is that there? Well, actually, the synchronization goes 2 ways. If I look at the list of devices registered in this IoT Hub, we will see that there is a Light O1 device. And that's the same device that we have seen here in the list of endpoints. Actually, to prove that it is a 2-way communication, let's delete it. I delete the device from the IoT Hub. The message that a device is deleted is picked up using the message routing. The Azure IoT Hub also has a nice feature that incoming messages could be routed to other services. It's really basic routing, but it can also listen to device lifecycle events when a device is created or deleted, and it even can listen to twin changes. If a device gets a reported property or a desired property, you can see it in here. So if we go back to the solution in here and I refresh it, then, well, no items found. The device is deleted. So there's a single point of truth. And to prove that, let's go in here. Let's go to the devices. And I have that temperature and humidity sensor. Let's take that one. I add a device. I call it TH01, temperature, humidity. and it's created. Well, at this moment, it's just created in the registry because, yeah, this is not enough information for the things network to actually do something with the device. There's no application EUI key, etc. Those secrets that are not in there. To do that, I have to do one more thing. This is the device. It has its own secrets to communicate normally, but what we're interested in is the device twin. And the device twin, as you can see, there's something like desired properties that you can fill in, and those will be sent to a device when it connects. There's also reported properties where the device can show its state. If something happened on the device and it's not normally telemetry, you can put it in the reported properties. So slow moving information like the battery status, that's something that you once in a while send to a device to the cloud. You put that in the reported properties. But I'm going to do something special with the device, and that's in here. Let me pick it up. The things that work comes with some extra information about how to work with that synchronization. And it's quite simple. The device twin also supports something like called tags. That's this part. Let me make it a little bit more. Okay, now it's in line. Okay, tags are values, key value pairs, or actually it could be a JSON object like here, which say something about the device behind it. You could put in there for which customer the device is registered, or for which office it is, or what is the purpose. Because if you have millions of devices and you want to have a subset to look at it, and a subset of that device and check out what's happening, you can use those tags. But we can also use it to say, okay, this is a LoRaWAN device, and these are the secrets, and this is the kind of device. And that's enough for the things at work to actually register the device inside their own console. So if I do save and I do close and I look back and I check, yeah, they take out the secret key, and that's why I can see that it's picked up. So if I go back to the portal and I refresh the list, here it is. Here we have a device created. So if I pick up the device, let's go to, and actually, as you can see, it's a air temperature humidity sensor, and it has the secrets. And if I go to the live data, I close it, and if I open the device, and let me, yeah, it starts. And there you can see that it is capable of joining. And here we see an uplink message. So if we go back to the Azure portal and I refresh the device twin, we can see that is actually says something in the reported part. Here it is, something about the hardware version, software version. Maybe if I refresh it again, oh, that's not refreshing. And I look at it, okay, it's still showing that same message, but it's always showing the last message that was arriving. Well, this is not the usual way to work with incoming telemetry. The incoming telemetry normally is picked up as a message, as a stream message. And we can look at that if I open another tool. That's the Azure IoT Explorer. That's a handy tool. If I attach to my service to my IoT Hub, I can see that there's an things that were the temperature humidity sensor, and I go for an other consumer group. I start, and now I'm listening to incoming devices messages. So again, just to speed up things, I reset it again. I close the device. Let me check the portal. It's always interesting to see if there's something happening. For some reason, I didn't hit the reset button good enough, I think. I have to pick the right sensor, of course. There are too many sensors laying around. That's why nothing is happening. So now I use the right one. Ah, there it is. Again, it's resetted. It tries to register that one-time registration, which is normally not done. And here you see an uplink message. So if I go into the right tooling, we see actually the message arriving. And here it is. There's some information in here. And actually we get a lot of information. The message is sufficient. And we even see the gateway which received the message, or the number of gateways. So you can do whatever you want with it. And here you see the battery information. So we have proved that we are capable of doing device registration at one point, and we can work with upload messages both as a streaming message and as a reported property. There's one more thing, and that's something with the uplink, the downlink message, sending a command back to a device. And I can show you a little bit of that in the documentation. I believe it's in here. If I go a little bit smaller, managing devices. And there's the device twin documentation. And if I look into that, then it says something, okay, decide properties. And here it says, okay, you can work with messages, downlink messages, and you have to put it in the desired properties. So let's do that. Let's take this one. This is the decoded payload, and in there's something like color red. It's a JSON message. I'm not sure if it will be known by the it will arrive at the device, but it's worth a try. Let's go to the device and let me device twin. And here's the decide properties. I just put it in there with a comma. Now I do it by hand, but this is all available with a API. So the IoT Hub is completely programmable, but for convenience, well, for now, for a demonstration, this is really nice. So I say, okay, let's send the decoded payload. It should be picked up by the console, and as you can see, it's actually picked up by the things that work, but it says there's no encoder available. That's interesting. because I have those payload formatters, the option for payload formatters for both uplink and downlink. The issue is that downlink is not made available for our solution. The stuff that we see here is not really what's happening. We had the uplink set to none, as you can see. That's because we use the payload formatters from the repository. The supplier of the hardware, they did the registration stuff, and they only supplied an uplink payload formatter and not a downlink formatter. You can override it, as you can see. You can say, okay, downlink formatter, I want to put in a one myself with JavaScript or some other stuff. But again, I didn't find time to figure this out, how it actually has to be. But the option is there, so that's great. What I would like to see is that a company like the manufacturer of these devices, that they actually put in a simplified payload formatter. I just have to send some JSON, and it's automatically changed into the byte array, complete with checksum and etc. etc. So let me figure out the right page for my presentation. Here it is. We've seen that resources are created, and we have seen that the IoT Hub makes a clever use of the extra routes regarding the twin changes and device lifecycle changes, and those are sent to the cloud, to the Things network. So this works quite okay, and with that, well, we can create a device in the IoT Hub. It's sent with the routing to an event hub. From there, it's picked up by the Azure Function. That one changes the stuff on the Things stack. Once a device is created, a message can be sent uplink towards the IoT Hub. It's sent both as a streaming message and as a reported property. So technically, we have to pay twice for the same message. And we are capable of working with downlink messages from the IoT Hub with JSON and send that as a byte array towards the device somewhere in the field. And that's all done with the clever use of the tags and the routes, etc., etc. And keep in mind, what we're seeing here, the device registration and the uplink stuff and the downlink registration, this is something that we could look at and say, okay, I have my own third-party solution, and now I can do something similar way, and I can connect actually any third-party solution to the cloud. So this is a nice example of how it could work. Okay, how's the time, Pete? Because I have one more thing, a small thing.
Oh yeah, go ahead. No, if you're that close to the end, then carry on. People have to hold it in.
Okay, very good. Well, there's one more thing. We have talked about a LoRa platform, and it's the things that work. It could be something else, like the commercial KPN one or LoRaWAN, or well, there are many platforms, but most of them are working with a global provider where anybody puts his messages in. So if you're interested in working with LoRa as a communication protocol, and it could work for you, but you're not really fond of those public solutions, why not start your own? Why not have your own private LoRa platform? It's possible. The Think stack is made available open source, and Benjamin KB, he wrote a nice article about how to host everything yourself in Azure.
And as it happens, myself and Benjamin on one of the first IoT Live end-to-end shows ran through how to do that over the course of 3 afternoons. So you can go and check that. That's out on YouTube. If you find me on YouTube, you'll find that on there as well.
Again, there's even this deploy to Azure button, which we have seen already twice. And it even comes with a basic calculation about how much it will cost you. For this price, you are capable of having a private backend, which is really nice. So this is the one more thing that I wanted to share with you. Okay, I've covered a lot. I've covered the Things Network, some Azure IoT, Azure IoT Central. We've seen some sensors, the private backend from Benjamin. And if you're interested, we will share this slide with you with all the backend information of all the information of the links. And I also put in some stuff regarding training material in MS Learn. It's already mentioned a number of times on the show. MS Learn is a learning portal from Microsoft where you can do free training about almost all Azure, every Azure resource that there is. And I put in a collection that I created regarding Azure IoT stuff. And you can use that as a starting point for the AZ220 exam, the Microsoft IoT Developer exam, and a specialty certificate. So that's it. Thank you for joining me, and there is some room for Q&A.
Absolutely, well done. That was fantastic as always, Sander. Thank you so much. That was cool. That brought back memories. Certainly that private detail that you've got there. I bought some stuff from a store, and it wasn't as easy as an API to be able to get those 3 pieces of information that you were talking about there, the private keys and GUIDs and stuff like that. They were supposed to send it on a piece of paper along with the thing that you buy, but they didn't do that. And also the API, rather the LoRaWAN gateway, I think there was 2 different versions of that as well. And the version I bought originally didn't work with what we wanted to do for some reason. Can't quite remember what the problem with it was. It didn't support the protocol or didn't support connecting to the Things network or something funny, I think. So I had to buy another one. And the one I rushed to get to buy came with the wrong plug as well. It came with your Euro plug rather than my GB
sorry about
plug.
that.
Yeah, I don't think you would have been happy with me landing at your doorstep saying I can't do my presentation, so I need to do it from here.
Well, I have a bunch of those adapters. So
yeah, that's what I had to do. So I went down to Tesco's and bought the Euro to GB converter for it, so I could get it done. So it arrived the day of the presentation, which was a bit scary. But yeah, I had to email the company and say, what are the codes? And they've got them all in a CSV apparently, and they just sent them over.
Very nice, very nice. Yes. The Things network itself and the LoRaWAN protocol and the way of registering devices, that itself is already a separate topic.
Yes.
This is quite big.
Yep.
So I try to simplify it a little bit and wave away the difficult parts. But yes, again, I do a lot with off-the-shelf devices, so that helps me. But yes, sometimes you have to use an API to get the keys, like the ones from the SenseCap. But for this one, I actually had to send an email to get my information, which is not quite scalable.
No, it's not.
And from this one, the secrets are actually on a sticker inside the box.
Yeah, that's what you want.
Where is the box?
Ah, well, and now where's your sticker with the? Yeah, exactly. Yeah.
Well, actually, that's the box that you see as the time travel stuff box.
Okay.
So it's there. Yes, yeah, those secrets are quite important, and they are so it's better to store them in some key vault. If the keys are lost or the company goes bankrupt, then you're lost and you can throw away your sensors.
Yeah, it's bad, isn't it?
Then it's just a paperweight.
Yep, exactly. But yeah, I think I've got the exact same gateway that you've got. Actually, it looks exactly the same. So it's plugged into the wall over there, I think.
That's possible. It's the Mqtt WAPS 8, something like that.
Yeah, I can't remember. I remember it definitely looks exactly the same as that.
So it's really nice. But I really love this little gadget because it's portable, and so it's nice for having a demonstration somewhere, and you're not sure if there's a LoRa gateway available. You can use something like this. Yes, there are so many sensors available already. I was at the Things Network, the Things conference. Okay, what is a conference? Maybe something to tell. That's when you have 2,000 people in the same room.
Well,
all talking about
that doesn't sound safe.
All interesting in the same topic, talking to each other within 1 meter or a few yards.
That's crazy. No one does that, surely.
No. Well, actually, in the past, back then, it was done, and it worked.
In the before times, yeah.
And there was a wall, something like 15 meters wide, 2 meters high, full of sensors. There are so many LoRa sensors available, it's I find it a very interesting protocol. There are, of course, competitors like narrowband IoT, but LoRa, the purpose that I need the sensors for, it works.
I like it. So, I mean, has anybody else got any questions there, or?
Is somebody already, or have somebody looked into the IoT Central applications? Have you played with it?
I did try the Azure IoT Dev Kit. It just uses Wi-Fi. It's not LoRa. It's been out a while now. I think that's a Seed Studio thing as well. But yeah, it worked, but then it just stopped working for some strange reason. I couldn't figure out why it stopped working. The data was coming in, but then it stopped. But there was no easy way of troubleshooting it really. So I kind of moved on and kind of rolled my own with Mosquito, Grafana, and InfluxDB, just for using at home. Kind of keeps it within your local network really, because it didn't need to go to the cloud. It just thought it might make it easier.
That's also in Internet of Things just having the stuff running on your local network. Is somebody already working with Azure IoT Hub or the platform as a service solution?
Yeah, see, Adriano's just posted that exact response in the chat there, that he's using IoT Central and is going to get back to IoT Hub soon.
Yes, well, I think the target for IoT Central is for makers who want to play with a simple solution, because you can start for free. If you only have 2 devices, you can run it for free. So you have a free platform with all the ruling and stuff in there. But if you're a company and you have several hundreds or maybe thousands of devices, and you want to have a simple dashboard and you don't have the programming skills or capacity available, then you just pay per device. And it's not for thousands of messages per day. It can be, but there's a basic pricing tier for, I believe, 3,000 messages a month for and then that costs less than €1. So that's interesting if you're not that much communicating. It's still 1,000 a day, so that's something like every 3 minutes, I believe. I'm not sure. 1,400 minutes. That's every 2 minutes, something like that. So that's okay.
I see. Sorry, Adriano, are you trying to say something, or are you?
Yeah. Hi everyone. I'm just like I've been using IoT Central because it was easier for me, because you're in a small group here in Brazil, and it was easier for me to deploy the solution, to connect the device to the cloud and export as well, because we have now in IoT Central the webhooks, which we can export the data to our database and do our applications. So like I've been using IoT Central as a solution, a temporary solution. As I said, we are planning to get back to IoT Hub. And one of my major difficulties, it was like, okay, I'm using IoT Central now because I guess how can I say, it gets all the solutions behind it, like streaming leads and so far. And so how can I do it, the step back again to build how can I say, a good IoT architecture? It's been one of my major difficulties now, and Sander, you brought some very good tips for us today, especially in this part of connections. Nowadays we've been using LoRaWAN as well, but we don't use the public like the Things network. We use some corporate solutions, and it was very good to speak to makers our mind open a little bit. I hope I like very much your talk.
Okay, thank you very much, and I'm glad that it can help you in your journey towards a better IoT architecture.
David Rodella, and by the way, nice to see you, David. Well, see you virtually, obviously. Is asked as well, what's the current status of the commercial adoption of LoRaWAN technology? Is the TTN widely used? And looking at the coverage map, it doesn't appear to have a very wide coverage. Are companies going private versus public?
Well, I'm not that attached towards the things at work. If I ask them about the adoption, they will say it's great. It's check out the coverage in your own region. There where you want to have your sensors, check out if there are sensors already. And keep in mind, it's a community network mostly. So if somebody needs to unplug his network cable for some reason, you have no gateway anymore. So personally, I think that having a private backend together with private gateways is the best solution, because in some way we always want to be in control, and we want to have the best coverage always 24/7. If that's not the case for you, if you can drop if you can cope with the situation that some messages will be lost, or there's maybe a few hours or few days no communication, if that's good for you, then you can go for a public one. There are commercial providers like for the things for LoRa. In the Netherlands, we have a company who's providing a countrywide commercial network. I'm not sure how that is with other countries, but then you go for that. Or you can also say, okay, let's skip LoRa, let's go for another platform, another communication layer, which is commercially available, like Narrowband IoT or Sigfox. So it depends on your use case.
Cool. Hope that helped, David. Any other questions? Silence. I guess not. Awesome.
Then I tried making just rolling their own LoRaWAN sensors.
Did you say, Sander, that in that Arduino package that there was a LoRaWAN chip on the board?
Oh no. This is the Things Uno. It's a really old board. I don't know if it even works with the version 3 portal nowadays, but this is a custom board, and as you can see, there's this silver chip on top of it. They provided it together. So they started with I believe an Arduino Uno, and they put some extra software on it. It's even a beta version. It's not a commercial solution. They later on provided this one as a commercial solution, but it's really nice for doing some tinkering. But you can also work with something like this, where you can actually buy little LoRa chips with in this case, with a antenna connector, so you can do your own tinkering.
I believe the gateways need to be 8-channel for version 3. I think version 2 you could build a single channel one, but I don't think you're allowed to do that anymore. Yeah, so you end up having to buy one.
Yeah, because this is I believe a single channel one.
Okay. Yeah, they're a lot more expensive. I think it's some a different Semtech chip.
Yes, this was something that I bought back in the days with the idea I'm going to build stuff myself. But well, nowadays the multi-channels are not that expensive, I believe. But
I've seen one on Moser for less than 100. Dragino 8-channel gateway. It's an indoor one.
Oh, the gateway. Sorry about that. The gateway.
Yeah, the gateway. You have to be 8-channel. If you couldn't build, if you tried to build your own gateway, you'd have to
correct.
use the supported hardware that's at least 8-channel.
Yeah, maybe that's good to know that the LoRaWAN protocol can be sent over multiple channels. There's something like 8 channels. So, and the message can hop from one channel to another. basically you need something on the gateway that looks at all 8 channels.
It listens on all of them, yeah, because they don't know what channel the client could be transmitting on. It could be on any of them. So I don't think they want single channel gateways on, because they're going to be hard potluck connecting to them, I suppose.
Yeah. So, and I have it somewhere laying around. I have a 2-channel gateway, a packet forwarder, laying around somewhere, and it was capable of reading messages on only 2 channels. So if a message came on another channel, it was lost. It was not picked up. So I only got 1 out of 4 messages.
It'd be okay for private use. You could just have all your clients on the same channel, but if you wanted to implement a public gateway, unless you knew what it was listening on, wouldn't really much use to anyone else.
Yeah, I'm not sure if I was in control of the channel where messages were sent. I believe I was not capable to change that, but this is somewhere 2016. So that's ages ago from in IoT perspective.
Yeah, it's changed a lot, hasn't it, since then on TTN and whatnot.
Alan Buxey's posted a couple of cool things with the Wio terminal that we were talking about earlier, and some LoRaWAN stuff that you can do with that. They're quite cool. Certainly the Wio LoRaWAN field tester. That looks like that's quite a cool device.
Oh, I did get that actually. I haven't used it yet.
Ah, cool.
Yeah, because I've got some other LoRa chips, and I wanted something to almost to use it as like kind of an analyzer, just to see what everything's configured correctly and listen to the traffic. So I thought I'd get that as well when I got the Wio terminal.
Yeah.
Well, cool. There are people who are war driving. I think it's called. They drive around with a car or with bicycle, and they try to communicate with gateways with a node which has a GPS. So then they can try to figure out what the distance is between the node and the gateway, and let's say something about the signal strength and availability.
Well, I think TTN encourage people to do that, to map out the network. I think it's something you can do. Yeah.
And this is for people a hobby. Actually, there are lots of experiments of the longest distance to get a package sent. There are numerous examples of weather balloons with a LoRa node underneath it, and they can up to hundreds of kilometers.
There was something launched into space, one of these CubeSats last year or the year before, and I think it failed. I don't think one of the antennas unfolded or something, but it was some kind of like research project, and the idea was that was supposed to communicate on LoRa and then some other frequency that's commonly used for like telemetry or something with satellites. And I think the telemetry frequency, in theory, if you got one of those ball things, you could listen to it, tune it to the right frequency and pick up some digital noise or something like that in theory. But I tried it, I couldn't hear anything. There was supposed to be a certain time you could look when it was going past and see if you could pick something up using a LoRa or that, but I don't think anyone heard anything because it failed, I think. Oh, it's a shame. Yeah,
it's the protocol is quite resilient. It's capable of traveling over a long distance, but it's of course the Earth is it's not flat. There's a curve, so you cannot go.
Don't say that too loudly. People are arguing with you.
It'll upset some people.
Sorry about that.
We're all on the back of a great big turtle, don't you know?
Yeah, it's on the back of loads of other turtles.
I'm interested in how they explain the horizon problem with a default antenna.
I'm sure they've got some sort of an explanation.
And well, in the Netherlands is quite flat. it's not completely flat, of course, but we don't have that. We haven't have any mountains or sufficient hills to put some antenna on top of a hill or a mountain. If you are capable of doing that, you have a really nice coverage.
I think it can it can pick signals up below the noise floor apparently somehow, because it's some chirp spread spectrum or something to do with, and it can it can differentiate it. As long as you have it on the really low data rate where it's literally like 18 bits a second or something like that, it's really slow, but it's enough. I mean, if you're only reading temperature, if it takes 10-20 seconds to transmit the data, but I think the only problem is the longer it takes to transmit the data, the more chance of interruption due to interference. So it's kind of a balance, I think. So you can't. So some of the really low data rates are only really usable if you've got like a clean RF environment, really, without anything else transmitting on the same frequency. So if you transmit faster, it's more reliable, but then your range is reduced. So, yeah.
Well, and that goes for all these protocols and all these frequency solutions, which are low powered and long distance. Narrowband IoT has a small solution. For example, if you want to do a firmware update, I believe they are capable of switching over for a short time to 3G or 4G,
Okay.
Get the update, and then close down again and go back to the normal low-powered solution.
Yeah, because that'll probably could use up to an amp of current just to transmit on 3G or something like that to 10 miles away to the nearest cell tower. Whereas your LoRaWANs was like 70 milliamps or something when it's transmitting on full power. Maybe
I
less.
don't know the specs by heart. This is a nice demonstration of having a third-party cloud and being smart with the webhooks and with the IoT Hub capabilities to actually connect stuff together.
I suppose before the integration that you could use, is there an MQTT bridge in Azure IoT?
Is there an
MQTT bridge in Azure IoT? So then you could have a client which subscribes to both and just swaps messages between TTN and Azure, but then you won't get the device registration. Well, you'd have to do it twice, wouldn't you?
There are some fancy stuff that you can do with the IoT Hub. I've not used it myself. I have to look it up. But it is capable, of course, of working with normally with MQTT messages or AMQP or even
that was
HTTP.
The main one's AMQP.
But you can put in your own protocol translator in the IoT Hub. There's some stuff that you have to do to work with your own protocols. So that could be a solution also for the integration, if you want to have some other stuff done. But I've not used it myself in a customer project. It's there, it's available, but I have not digged into it. I believe it's part of the ASA 220 exam, Pete.
Which part exactly was that? That's part of it.
That's the IoT Hub has
the protocols that it supports.
It supports protocol, but there's a custom protocol solution. You can do something with ingesting other stuff. You have to.
Yeah, I mean, by default, it'll do AMQP, MQTT, or HTTPS. They're the three kind of main ones. But obviously, I mean, you can make your own front-facing gateway for any protocol and then translate it to any of those other three. Obviously, if you can't do WebSockets, you can do it over HTTPS if you like instead. But they're kind of the three that it'll accept.
Yeah.
Cool.
There's
Any
no
other questions?
ETN gateways near where I live. I just checked. Not. I mean, I think there's one 10 miles away, but I don't think I'd reach that. Not with the topography of the land. It's you need maybe a line of. I think line of sight. There was that Swiss guy did some videos on YouTube. The Andreas Spiess, he did some kind of world record lower. I think he used some software to work out where we'd have line of sight on the Earth. There's some software for mapping out terrain. So he set something up from his house to somewhere that had a line of sight that was 50 kilometers, maybe something. He managed to get a signal, but it was I think he went up a tower to do it. Yeah. That's interesting to watch.
That's a cute kitten that you've.
They just started jumping out, and only had him a week.
Oh,
Jumping around everywhere. Sleeping next to my keyboard. I had to move one of the heads off my F2 key the other day. It was stepped on some keys earlier and started some video playing or something. I don't know what happened.
Could be worse.
Yeah.
Oh, geez. Yeah, if I leave my laptop open anywhere, my cat comes and sits on the keyboard. So I have to tilt it forward if I remember. That, and she comes and drinks my bloody water. I just have a pint of water next to me or something.
Oh, you got to watch for that. Yeah, I've got some water here. I haven't sniffed it, but...
Yeah, it's amazing how far she can get her head into it, actually, as a fully grown cat. Pint glass.
Very comical, yeah, because there's two here and they just spend... They scrap for a bit and then sleep for a bit and then scrap and then sleep.
Right, well, I mean, if there's no other questions, then it's 9:15, so I'm going to let you all go and enjoy the rest of your evening. Okay. So, obviously, thanks so much to Sander for that talk. That was fantastic. Obviously, do keep, if you've not done so yet, then either tweet or if you can't tweet, then put a message out on any other social media platform by all means. And then in the next few days, I'll pick a couple of people, actually, because I've got a couple of licenses. I'll pick a couple of people, so you've got twice as much chance this month to win a JetBrains license. So thank you so much for coming along. 24th of February, all being well, we'll have Cliff Aegis along to talk about .NET Nano framework on an ESP32. So that'll be a good event to come to as well. So. Yeah,
it would be nice if there was integration also for Iot terminal.
For .NET Nano framework, you mean?
Yeah.
Yeah, that's true. That would be good, wouldn't it? We'll have to ask what's his face, Jose Samoes, about that. See what he's up to. Cool. All right, everyone. Thanks so much, and I'll catch you again next month.
Yeah, thanks.
See you then.
Thank you very much.
Thank you for hosting this session. And thank you, Sander. Great presentation. See you around. Take care, everyone.
You're welcome.
Cheers.